Ever wondered why the moon seems to change shape in the sky? One night it's a thin sliver, the next it's a bright full circle. But what really causes this? You might think it's just some random cosmic event, but trust me, it's all about the moon's orbit around Earth. Stick around and I'll show you exactly how the moon's phases work. Okay, let's get straight to it. The moon's phases aren't magic or mystery. They're the result of a predictable, repeatable process that happens over 29.5 days. This process involves the moon's orbit around Earth, the position of the sun, and the way light hits the moon. And by the way, this isn't just something cool to watch. It affects everything from the tides to ancient timekeeping. In the next few minutes, you're going to understand exactly why the moon looks different every night and what those phases mean for us on Earth. But here's the catch. Most people don't realize how much these phases impact our lives. Have you ever thought about how the phases affect the tides, or even the way people used to track time? And why does the full moon always seem so much bigger than any other phase? If you've ever wondered about any of these questions, you're in the right place. By the end of this video, the moon's phases will make so much sense, you'll feel like an expert. First, let's break down the basic phases of the moon. There are 8 primary phases in the lunar cycle, each one representing a different part of the moon's journey around Earth. These phases aren't random, and they aren't about the moon changing. It's all about how much of the moon's illuminated half we can see from Earth, based on its position relative to the sun. The new moon is the first phase of the cycle. During this phase, the moon is directly between Earth and the sun. Because the illuminated side of the moon is facing away from Earth, we can't see it. The moon is new because it marks the start of a new cycle. This phase is tricky because it's the one we most often miss, but it's a key player in the whole process. Waxing crescent. After the new moon, the moon starts to move along its orbit, and we begin to see a tiny sliver of light on the right side, in the northern hemisphere. This phase is called the waxing crescent. Waxing just means the illuminated portion is getting bigger, so each night we see a little more of the moon until it's about half lit. First quarter. By the time we reach the first quarter, the moon has completed about a quarter of its orbit. We can see exactly half of the moon's surface. This is the classic half moon we're all familiar with. Now, here's the thing. It's called the first quarter because it happens 1/4 of the way through the lunar cycle, not because it's a perfect quarter of the moon's size. Waxing gibbous. Now the moon is more than halfway through its orbit, and the illuminated side continues to grow. This phase is called the waxing gibbous. Gibbous means more than half, but not fully illuminated. You'll notice that during this phase, the moon looks pretty close to full, but not quite there. Waning gibbous. After the full moon, the light starts to shrink. This phase is called the waning gibbous, and it happens as the moon starts to move away from the sun. The illuminated portion begins to decrease, but the moon is still more than half lit. Last quarter. Next, we reach the last quarter, which is like the first quarter, but in reverse. Now, the opposite side of the moon is lit up, and we again see half of the moon's surface. This phase occurs when the moon has completed about 3/4 of its orbit. This is the third and final half moon of the cycle. Waning crescent. Finally, we have the waning crescent, the last phase before the new moon. The illuminated portion of the moon continues to shrink until only a tiny sliver remains visible. The cycle ends here and begins again with the new moon. The science behind the phases. So now that we know what the phases are, let's talk about why they happen. The phases of the moon are the result of its orbit around Earth. The moon is always half illuminated by the sun, but we see different amounts of that illumination depending on the moon's position. Think of it like this. The sun is shining on one side of the moon at all times, but because the moon is constantly moving around Earth, the angle at which we view it changes. Sometimes we see a lot of the illuminated side, and other times we see just a little. The key thing to remember here is that the moon doesn't actually change shape. The phases are just our perspective from Earth. Why does it matter? Tides. The most obvious impact of the moon's phases is on tides. As the moon's position changes, so does the strength of its gravitational pull on Earth's oceans. When the Earth, Sun, and Moon are aligned during the new and full moons, the gravitational pull is stronger, which leads to spring tides, higher than usual high tides and lower than usual low tides. On the flip side, when the moon is in its quarter phases, first and last quarter, the tides are weaker and are called neap tides. Timekeeping. In ancient times, people relied on the moon's phases to track time. Some cultures even used lunar calendars to determine when to plant crops, harvest, or celebrate religious festivals. The moon cycle gave people a natural rhythm to follow, which was crucial before we had clocks and technology. Cultural significance? The moon has been a symbol in many cultures for thousands of years. From guiding sailors at night to influencing the way people measure time, the moon has always held a sense of mystery. Even today, many cultures still celebrate the phases of the moon, especially the full moon. Festivals, rituals, and even personal beliefs are all tied to the moon's cycle. To wrap it up, the moon's phases are not just a beautiful sight in the night sky. They're part of a predictable cycle that has been affecting life on Earth for billions of years. From the way we track time to the tides that shape our coastlines, the moon's phases have a real impact on our world. And now, when you look up at the sky, you'll understand exactly why the moon looks the way it does. It's all about its orbit around Earth, the sun's light, and the way we see it. If you found this breakdown of the